Hello, welcome to Memory, and here we're going to focus in particular on memory failures and also improving memory. Let's begin by understanding memory failures and recognizing that there's a long history in the study of memory failures. One of the phenomena that was studied early on is the phenomena that we might call partial retrieval, and a little bit more informally, we might call this the tip of the tongue phenomena. We can define this as a retrieval failure in which one can recall features of the target item, such as the first letter or rhyming words, and yet it is still a retrieval failure. That is to say, we can't retrieve the entire word. Interestingly, this phenomena, the tip of the tongue phenomena, had been known to and investigated by William James. He described the phenomena back in the 1890s, even though he didn't call it the tip of the tongue phenomena at the time. In more recent times, researchers have investigated the tip of the tongue phenomena, and they've begun to investigate the underlying neural biology. In this slide, we can see a diagram of the brain, and just to help orient you, the back of the brain is over here, here's the front of the brain. We've now sliced the brain in a mid-sagittal fashion, and we're looking at it from the side. So here's the corpus callosum. This, as you might remember, connects the left and right portions of the brain. Here's the frontal lobe, so the person's eyes would be on this side. And we're going to focus on the anterior cingulate gyrus. So anterior means toward the front of the brain. And this cingulate gyrus appears to be playing an important role in the tip of the tongue phenomena. So it's interesting that this seems to be engaged when there is some kind of error detection. That is, the person seems to be aware that they have some information about an item to be retrieved, but they don't have perfect information about it. They know that they're struggling with this. Fascinatingly, the anterior cingulate has also been implicated in other kinds of error detection or conflict resolution. It even becomes active when people are considering moral dilemmas. While we're on the slide and looking at different portions of the brain, we can remind ourselves of the hippocampal gyrus. In an earlier video, we saw that the hippocampus plays an important role in the consolidation of memories. Okay, let's see if we can go on to learn about other aspects of this phenomenon of forgetting. In this slide, we have a picture of Hermann Ebbinghaus, who you might remember from an earlier video. Ebbinghaus had done some important work where he identified the serial position effect. And if you can follow my cursor now, you can see that I'm tracing out a U-shape. This U-shape refers to Ebbinghaus's serial position effect, and in that we had a primacy effect and also a recency effect. That was the condition in which we had the earlier words in a list being recalled with greater frequency, and the words later in the list also being recalled with greater frequency, and those in the intermediate portions of the list being forgotten. Ebbinghaus tried to quantify forgetting rates, and he developed a series of curves, all of which were described by this equation. R is equal to E to the minus T over S. So here, R is the memory retention. This is our dependent variable in these psychology experiments. We're trying to understand to what extent there is retention of information that we learned earlier. This is our dependent variable. We typically plot it here on the y-axis. We also have these other terms, and one includes the S, which is the relative strength of the memory. Another is T, and that's the total amount of time that has elapsed since we've tried to memorize this information. And of course, we also have E. Some students will recognize E as Euler's number. It's a mathematical constant similar to pi in certain ways, which is also a mathematical constant. Here it is to 9 digits of precision. What's really important about this is not so much that you memorize the formula or the individual components, but rather that very early on, even in the 1800s, psychological researchers were finding the orderliness to our forgetting. And it was so orderly that they could make equations that would describe the rate of forgetting, and we got pretty good approximations between these equations and the empirically observed values of forgetting. Contemporarily, researchers tend to focus on two main factors that influence forgetting, and these are the retention interval and also new learning. So let's just remind ourselves that the retention interval is the time between learning and retrieval, and that can be experimentally manipulated. That can be the number of days or the number of hours between when we're encoding and when we're asked to retrieve. The other factor, new learning, we might think of as recently acquired information that can disrupt memory of older information. And what's important is that these two factors tend to be correlated. That is, as we allow a greater and greater retention interval, let's say a greater number of days between when we encoded and when we're asked to retrieve, we've had a greater opportunity to acquire new information, just in the passage of everyday events in everyday life. So these two factors tend to be correlated, and they both influence the rate at which forgetting occurs. Importantly, we can think about forgetting as a type of memory intrusion. That is, we have factors that are intruding on our memory, and this is synonymous essentially with forgetting. So let's now consider some memory intrusions, and we'll do this over a series of slides. Psychologists identify two different kinds of interference that constitute examples of memory intrusions. One is called proactive interference, and we can define this as the phenomena that occurs when previously learned information impedes the recall of newly learned information. We can sum that up by saying more simply, the old disrupts the new. Can you say that with me? The old disrupts the new. This is said to be proactive interference. And then we have a complementary kind of interference, which is called retroactive interference. And this is the phenomena that occurs when newly learned information impedes the recall of previously learned information. Here, the new disrupts the old. Can you say that with me? The new disrupts the old. So these are two different varieties of memory intrusions, proactive interference and retroactive interference. Now, in modern times, we can learn a little bit about the neurobiology that underlies these different kinds of memory intrusions, these different varieties of interference, and some fMRI evidence suggests that the prefrontal cortex, again that's over on this side, helps to resolve or overcome proactive interference. And here's a PubMed citation for those of you who might be interested in learning more about this. Again, prefrontal cortex here, and this is going to be the back of the brain. This is the region that's going to help us overcome proactive interference. That's when the old disrupts the new. Okay, let's move on and talk about other varieties of memory intrusions. One that many people know about is the phenomena of amnesia. What fewer people realize is that amnesia comes in two broad categories. There is anterograde amnesia, and this is a memory deficit in which the patient is unable to form memories of information acquired after brain trauma. So this is an inability to form new memories. We can contrast that with retrograde amnesia, which is a memory deficit in which the patient loses information acquired before the brain trauma. So this is an inability to acquire some older information that occurred just before the moment of injury. Most people would construe the anterograde amnesia as the greater deficit. It's ongoing. It's an inability to form new memories. So as an interim summary, we have many different varieties of memory intrusions, and these include different kinds of interference, proactive interference, retroactive interference, and we have two different varieties of amnesia, anterograde and retrograde amnesia. Contrasting those broad categories, I would like to point out that the interference is something that happens in day-to-day life all the time. By contrast, the amnesias are occurring only when we have some kind of traumatic brain injury. So that's a more specialized case. Okay, let's go on to see another variety of memory intrusion, and this is the misinformation effect, the phenomena in which memory becomes less accurate because of post-event information. A leading researcher in the phenomena known as the misinformation effect is Dr. Elizabeth Loftus. Let's consider how Dr. Loftus and her researchers might perform an experiment on the misinformation effect. Dr. Loftus might interview you and say your parent, and she's interviewing you and your parents separately. And during the interview with your parents, maybe she learns something about your past as a very young child. For example, maybe she learns that the family had taken a trip to Disneyland or to Disney World. Maybe she also learns that during that visit to Disneyland or Disney World, you had been frightened by something. And maybe that something had been a Mickey Mouse or a Donald Duck character that was walking around Disneyland or Disney World. What Dr. Loftus will do is, when she's interviewing you as the participant, she will give you some misinformation mixed in with some actually correct information. That is, she might tell you that, oh, your parents have informed me that your family had taken a trip to Disneyland or to Disney World, and that you had a scary encounter with a character. Now here comes the misinformation. She might tell you that the character that had scared you was Bugs Bunny. Bugs Bunny is actually a Warner Brothers character. Bugs Bunny is not a Disney character. So it is at least possible that you could have been scared by a Donald Duck or by a Mickey Mouse. Those are Disney characters. But it is not possible that you were scared by a large and roaming Bugs Bunny, because a Warner Brothers character would never be legally allowed for copyright reasons inside of Disney World. So Dr. Loftus is mixing in some misinformation with the actual information. Weeks later, Dr. Loftus and her graduate students might inquire about your memories of this event, and all of a sudden you start to incorporate this fictitious character. That is to say that Bugs Bunny will now be part of your memory, even though it didn't actually occur back in your childhood. Rather, this false memory had been implanted during the initial interview with Dr. Loftus. This is one of the ways that psychologists can experimentally control misinformation, even about autobiographical events. It might be autobiographically true that you and your family really did visit Disneyland or Disney World. It might be autobiographically true that you really were scared by some roaming large character. It could not have been true that that character was Bugs Bunny. And so here we have the chance to experimentally manipulate autobiographical information and investigate experimentally the misinformation effect. So we can say then that misinformation is itself a type of memory intrusion. Let's go on to other types of memory intrusions. And to understand one important type of memory intrusion, we need to develop some new vocabulary. Specifically, we need to understand fully the concept of a schema, which we can define as organized bits of knowledge. Can we say that together as a mantra? Schemas are organized bits of knowledge. There you go. Now, schemas help to organize complex information, but they can also generate errors. In other words, schemas themselves, although generally helpful, do lead to memory intrusions. And there's a very famous paradigm known as the Diess-Roediger-McDermott paradigm, or the DRM more simply stated. And this is a paradigm that's a procedure in cognitive psychology that's used to study false memories in humans. And we saw an example of false memories a moment ago in Dr. Loftus's work. Here we have something like a lure that is semantically or thematically related to some kinds of distractor items. So, for example, it might be the case that we have a bunch of words that we'd like you to recall, and all those words relate to sleeping every night. We might have the word nighttime, we might have the word pajamas, we might have the word pillow, we might have the word bed. We never actually use the word sleep, though, in our list of words. And yet, all words are very obviously related to the word sleep. This is a semantically related lure that isn't physically present in the list of words, and yet people tend to remember the word sleep even though it wasn't physically there. This is taking advantage of schemas, the organized bits of knowledge that we have about the things that we do when we are sleeping. We associate certain words and certain activities with sleeping. These schemas generally help us, but they also can be a source of memory intrusion, a source of memory errors. Now, what's particularly fascinating about the DRM paradigm is it makes a very clear point, and that is that memory is really not like a tape recorder. So we've crossed out the tape recorder here, and this is a very old-fashioned tape recorder, but you get the point. And this is important because early in the history of memory research, it was thought that maybe we tend to record things verbatim into memory. But what Dr. Loftus's research shows us, and what the DRM research shows us, is that we actually don't have a strict recording of what was physically in the environment. Instead, memory is not like a tape recorder. Memory is constructive, and we're going to make that a mantra. Can you say it with me? Memory is constructive. Similarly, we can say that memory is top-down. Say that with me? Memory is top-down. There we go. So we have these two mantras, and the point here is that memory is not bottom-up. We've previously contrasted top-down processes from bottom-up processes, and we had an example similar to what we see at the bottom of this slide. Here, we can see that this particular symbol is identical in these two different contexts. In one context, it acts as if it were the letter H in THE, the word the. Here, that exact same symbol is acting as if it were the letter A, the word cat. So we have the cat, but the same bottom-up symbol, that is the same physical stimulus, is playing two different roles in these two different contexts. And we're able to see this as an H and this as an A because we have knowledge that goes beyond the stimulus factors associated with this particular symbol. So here's an oldie but goodie. Let's remind ourselves of a slide we've seen before. And this is our top-down versus bottom-up slide. We said previously that top-down is knowledge-driven, and it requires information that goes beyond the stimulus. By contrast, the bottom-up processes are said to be stimulus-driven. They rely entirely on the neural response to the stimulation. So again, the physical properties of the stimulus, we see this as being in blue. We see the font as being a particular size. We also saw a similar demo as in the last slide. Here we had an A, B, and C. In an earlier demo, we had a 12, 13, and 14. And under certain stimulus conditions, the 13 can look very much like a B. And even when we hold that physical stimulation constant, we might recognize this as a B in an alphabetic context, and this is a 13 in a numeric context. So this gives us a chance to revisit top-down versus bottom-up processes. And as we've seen in Dr. Loftus's example, and also in the DRM paradigm, memory is not working like a tape recorder, which would have been true if we were physically recording all the properties of the stimulus. Instead, memory is constructive. It's operating in a top-down manner via schemas, these organized bits of knowledge. Okay, so having noted that memory is top-down, and we've noted lots of different ways of having memory intrusions, we can now go to the flip side and talk about some ways of improving memory. One way to improve memory is through the simple use of mnemonics, any learning technique that aids information retention. So here's one that you may have seen before, and this is kind of fun. Sometimes people have trouble remembering which months of the year have 31 days. So we can use some kind of technique that might aid in the retention of those particular months that do have 31 days. And it turns out that just by chance, if you were to start naming the months and pointing to your pinky knuckle, and then the small crevice in between your pinky knuckle and your fourth finger knuckle, you would have a place to put another month, and every time you point to a new location, either a knuckle or the space between a knuckle, you name a different month of the year. Interestingly, whatever lands on a knuckle and not on the crevice in between happens to be a month that has 31 days. So this would be a simple technique that would aid in your retention of which months of the year have 31 days and which have some number of days other than 31. It's a knuckle trick. Now, the knuckle trick is relatively idiosyncratic. It just happens to be that we got lucky on this one. We need something a little bit more flexible, and memory researchers often recommend 3 different mnemonic techniques, the first of which is the method of loci. Loci is a word that goes back to the ancient world and refers to location. So this would be the idea in the method of loci. Think of some location that you know really well. For example, it might be that you understand your college campus really well in a spatial way. You know where the dormitory is, you know where the dining halls are, you know where the bookstore is, you know where your classrooms are. Okay, those are maybe 4 or 5 or 6 locations that you can just recall very, very simply. So let's say that you're going to the grocery store and you want to remember a list of items. You can visualize seeing the very first item on your list as being in your dormitory room. The second item can be at the dining hall in your imagination. The third item could be in one of your classrooms, and the fourth item could be in another one of your classrooms. And as you're trying to recall in the grocery store, what was my list of items? Well, you can now take a mental walk from location to location to location and pick up the items that you had encoded into memory. That tends to be a very powerful way to recall a list of words. Another mnemonic device is by using an association that's based on rhyming. We have rhyming schema. And some memory researchers would recommend something like this. Let's say that you have a list of 5 items that you want to recall, again at the grocery store. You can use a rhyming scheme, which is something like 1 is a bun. So imagine seeing a really large bun, and the first item on your shopping list will be something that you place in your visual mental imagery on top of a bun. Okay, and you need to see that picture. There's the bun, and there's the first item to be recalled laying on the bun. 2 is a shoe. 2 and shoe rhyme. Imagine a large brown shoe, if you would. And it's good to give these colors because they help you get a little bit more vivid mental imagery. Imagine sticking the second item on your shopping cart into a large brown shoe. 2 is a shoe. 3 is a tree. Think of a tree that you recall from your early childhood or from your growing up years. Imagine the third item on your shopping list dangling from that tree, and it's rocking back and forth. It's good to give it some activity. It's good to make all of these moving. It tends to help people remember things. Here's another idea. Here's 4. We're up to the 4th item in our rhyming scheme, and 4 is a door. So think of maybe the front door on your home or the front door to some building that you're very familiar with. And now you've got a poster on the front door that is the 4th item on your shopping list. 5 is a hive. 5 and hive rhyme. So now we want to see a beehive dangling from a tree, maybe the same tree that you had earlier for number 3. And in that beehive, you're sticking the 5th item on your shopping list, and so forth. So 1 is a bun, 2 is a shoe, 3 is a tree, 4 is a door, 5 is a hive. This is an excellent mnemonic for learning new information. As we've mentioned previously, you can put each of those items in your rhyming scheme into some kind of activity. Alternatively, you can put the items into activity with each other. So let's say that you want to remember 3 items while you're shopping. Maybe it's a battery, and maybe you need to pick up some orange juice and also a loaf of bread. You can use active mental imagery by imagining that the battery is now hooked up by wires to a carton of orange juice, and the battery is actually making the orange juice spill over and land on top of the bread. If you can mentally see all of that, you'll have a greater chance of recalling it than you might if you were just trying to, by rote memory, say battery, orange juice, and bread time and time again. Rote memory tends to be less effective than using these mnemonic strategies. So these are 3 mnemonic strategies, and there are others as well, but these are 3 that psychologists have found to be very powerful and that students can typically use even when they're studying for tests. Okay, let's move on and talk about other ways of improving memory. And one of these is known as encoding specificity. We can define encoding specificity as the principle that states memory will be most effective when retrieval and acquisition contexts are similar. So here's an example. A psychology professor may provide hints, we might call these retrieval cues, to an answer by reminding students of the context in which the memory was acquired. So maybe in a particular laboratory study, the group went outside of the building and engaged in some exercise. If 2 or 3 months later, in the same semester, the psychology professor wants to call your memory back to that event or some information that you learned in the event, the psychology professor might say something like, "Do you remember when we went outside for that particular lab period?" That alone might be enough to trigger a memory. It's a retrieval cue that will help you now pull from memory some of the details from that particular episode. We might call this process context reinstatement. We're reinstating the environment in which the memory was initially encoded. Memory researchers have done a lot of work on encoding specificity, and one of the most famous studies is very informally referred to as the diving study. In this study, what the researchers did was they had a bunch of divers learn different lists of words. Some of the words were learned above water, and then they put on their scuba gear, they went underwater, and they learned a different list of words. And those are shown here in this graph in the blue when the encoding or the practice phase was occurring above water, and in red also when the practice phase was occurring with the scuba equipment on underwater. Subsequently, the researchers tested the recall of those words. So on the y-axis here, we're plotting the number of words recalled. Now the recall phase of the study occurred in 2 different contexts. It occurred above water and also underwater. And a very interesting pattern arose. As you can see here, when people were asked to retrieve the information that they had learned earlier, and that information had been encoded above water, well, in that case, we had a relatively high level of words recalled. And this is the case because we had a match between the encoding context and the retrieval context. They were both above water. We can contrast that with a mismatch between the encoding context, which here occurred underwater, and the retrieval context, which here was above water. So now these are words that are not intrinsically more difficult to recall, but because we had a context manipulation, we can see a difference between the blue and the red here, and likewise we can get the complementary set of results over on the right side of this graph, where we now change the retrieval context to having the divers recall their words now underwater. Some of those words, shown here in red, were encoded when the divers had gone underwater previously, but some of those words that they were asked to recall underwater had been initially encoded above water. And again, we see now the complementary pattern. Here, when there is a match for the encoding and retrieval context, we tend to get a very strong level of recall. When there's a mismatch, we have a reduced level of recall. What's important in this graph, too, is to notice that we do have an interaction effect. That is, the effect of one variable, the encoding context, depends very much on the level of the other variable. Our other variable is the retrieval context, and it has 2 levels. There is the above water level and the underwater level for the retrieval context, and similarly above water and underwater were the 2 different levels of our encoding context variable. So we have a 2x2, and we have a 2x2 interaction here, because the effect of one variable, say the encoding variable, depends on the level of the retrieval variable, the other variable. At this level, blue beats red, so above water encoding is associated with higher performance than is underwater encoding, and that pattern reverses at the other level of the retrieval context variable. So this is a really nice example of a 2x2 interaction effect. One other point to notice is that we don't have any main effects for retrieval context. That is to say, the average retrieval for the above water condition is midway between these two values. It's probably about 10 words. Similarly, on this side, we have about a 10-word average. So on average, the above water and underwater retrieval contexts are generating about 10. Similarly, in the comparison of the blue versus the red parameters, that is the parameter that's encoding the context that is occurring during encoding, we would have the blues averaging out to about 10, the reds averaging out to about 10. So there's no main effect for encoding context. That is, there's no difference between these two levels of the encoding context variable, and there's no difference between the two levels of the retrieval context variable, but there's a very strong interaction effect. Okay, so we've reviewed some of the research on how we can improve memory by matching the encoding context to the retrieval context. Topics for discussion that I will not elaborate on here, but interesting ideas have come up recently on the use of methylphenidate as a cognitive enhancing drug. And you might know certain students who have taken methylphenidate as a cognitive enhancing drug. It makes for a very interesting discussion. More recently, there's been a lot of conversation about the phenomena of drug-induced amnesia, particularly as it pertains to erasing traumatic memories, perhaps for people who are struggling with PTSD or other kinds of traumatic memories. Okay, thanks for watching.